Hi everybody, my name is Professor Rad, and today we're going to simplify fractions by using the prime factorization. So we'll work through a few examples using this technique, and you can kind of see I've got some loose leaf over here because I'm going to need some scrap paper. So here's how this method works. If I'm going to simplify 30 over 105 using prime factorization, I need to find the prime factorization of 30 and the prime factorization of 105. So that means I'm going to have to make some factor trees. So that's why I have my scrap paper handy. So I'm going to make a factor tree for 30. And remember, there are always multiple ways you can create your factor trees. So the way that I break it down might not be the way that you break it down. When I look at 30, I notice that it ends in a 0, which means 10 is going to go into 30. So 10 goes into 30 3 times. And just as a check, 3 times 10 will get me 30. 3 is prime, so I'm going to circle it. And then I know that 10 breaks down into 2 times 5. Each of those numbers are prime, so I'm going to circle them. So over here, my 30 over 105, I'm going to write 30 as its prime factorization, which is 2 times 5 times 3. All right, now we're going to do the same thing with the denominator. So we're going to find the prime factorization of 105. So over on my scrap paper, I should probably label this as part A. On my scrap paper, let's break down 105. I notice that it ends in a 5, so I bet 5 will work. So 105 divided by 5 gives me 21. So 5 times 21. I know that 5 is a prime number, so I'm going to circle that. And 21 I know is going to split into 3 times 7. So 3 is prime and 7 is prime. So that's it for our factor tree for 105. So I'm going to write the prime factorization of 105 below. 5 times 3 times 7. All right, so I've got my 2 factor trees made, and I've got the prime factorizations on the top and bottom. So here's how we use that to help us simplify. I think of it kind of like as a game. I think that's why I like this method the best, because at the end I get to play a game. So the game is anything that's up top is going to cancel if it has a matching partner below. So for example, I have a 3 up top and a 3 down below. So these guys are going to cancel each other out. Then I have a 5 up top and a 5 below. So these guys cancel each other out. And then the only remaining factor up top is 2. And the only remaining factor in the bottom is 7. So when I'm all said and done, I multiply whatever's left up top and I multiply whatever's left in the bottom for my new numerator and denominator. Since all I have left is a 2, that's my numerator. And since all I have left in the bottom is 7, that's my denominator. So 30 over 105 is going to simplify into 2 sevenths. And that's it. That's all we need to do. Now I am going to bring up my work from the last video just so we can see what's going on here. So if I bring up my work from the last video, when we simplified 30 over 105, what we did is we divided the top and bottom both by 5. That gave us 6 over 21. And then we divided top and bottom by 3, and that gave us 2 sevenths. So notice that the numbers that we divided the top and bottom by were the same as the things that wound up canceling. I canceled 2 3s. And at one point we divided by 3. I canceled 2 5s, and at one point I divided by 5s. And then in the end, we got the same answer either way. So the reason the prime factorization works is because what it does is it allows us to find all the numbers we could have divided by in one go by listing all those prime factors. All right, so let's try part B. See if I can get everything on the screen here. My table's a little small. So for part B, we've got 220 over 42. So we're going to make factor trees for 220 and for 42. Again, I notice that 220 ends in a 0, so I know that 10 is going to go in 22 times. And I know that 10 is going to split into 2 times 5, and both of those are prime. 22 is an even number, so I know 2 is going to work. And 2 goes into 22 11 times. And both of those are prime. So the prime factorization of 220 is going to be 2 times 5 times 2 times 11. So I have 2 times 5 times 2 times 11. Now this seems like a good point to remind you that your factor tree can look different than mine. So maybe, for example, instead of dividing by 10, maybe instead of dividing by 10, you divided by 2 right away. And when you divided by 2, you got 110. That's totally fine because you should end up with the same factors in the end. They might be in a different order, but again, that's okay. That's because multiplication is commutative. So when we're multiplying, the order doesn't matter. So make your factor trees however you do. What's important is that your prime factors at the end should be the same as my prime factors at the end. Okay, let's try 42. And now 42 I recognize as an even number, so I know 2 is going to work. That gives me 21. And 21 I know is 3 times 7. So for the denominator, our factors are 2, 3, and 7. So we have 2 times 3 times 7. Okay, now it's time for our favorite part. We get to play a game. Who up top can cancel with who below? So I notice, for example, we've got a 2 on the top and on the bottom. So these 2's cancel. And then I have another 2 up top, but this 2 I already used as part of a canceling, so it's not there anymore. So there aren't any more 2's down below, so this 2 can't cancel. So in fact, nothing else cancels. So that means my new numerator is going to be whatever this works out to be. So 5 times 2 times 11 is 110. So that's going to be 110 up top. And then down below, we have 3 times 7, and that's 21 down below. All right, so I have a couple more problems. So what I'm going to do is I'm going to work through my factor trees for both of these numerators and denominators. Then I'm going to write out my prime factorization, and then I'm going to come back because something kind of weird is going to happen in both of these, and I want to make sure we know what the weirdness means. So why don't you pause the video and work through the factor trees for each of these, write out the prime factorizations, and then do any canceling you can see, and something weird should happen. So I'll see you in a moment. Whew, all right. So I've got my factor trees for both questions over here on the right, but to fit everything on screen, I'm covering up part D at the moment. So let's look at part C. So for part C, when I did my factor tree for 16, I got a bunch of 2's. And then 144 was like a monster of a tree. And again, your tree might look different than mine for 144, and that's okay. In the end, I ended up with 4 factors that were 2 and 2 factors of 3. So in the top, I got 2 times 2 times 2 times 2. And in the bottom, I had 2 times 2 times 2 times 3 times 2 times 3. And again, the order of the factors doesn't matter. Okay, so if you had all your 3's at the end, or you had the 3's at the beginning, or wherever, it doesn't matter. What I didn't do yet was I didn't do my canceling because I wanted to make sure we could clearly see our prime factorization when we went to review. But now I get to cancel. Hooray! So this 2 is going to cancel with this 2 down here. Now I still have another 2 up top, and I've got lots of 2's that can cancel with down below. It doesn't matter which 2 I cancel it with, for example. So if I wanted to, I could cancel this 2 with this 2 over here. That doesn't matter. So however you're canceling your 2's, it's okay. All right. So in the end, though, what I notice is that all the 2's that were up top ended up canceling out because they each had a 2 in the bottom. So this is the weird thing I kind of warned us about, where something weird can happen. And in this case, everything that canceled out on one side. When we're doing this canceling, what we're really doing is dividing. So what ends up happening is you get a 1 up top. And that's because, for example, when this 2 gets divided by the 2 down below, 2 divided by 2 is 1. So we end up with a 1 in the place. So when an entire side cancels out, that means there's a 1 there. Then in the bottom, I had 2 3's remaining. So 3 times 3 is 9. So my denominator is a 9. Let's take a look at part D. Oh, can I fit it all? I don't know. If I really want to make it work, I think I can. Yeah, there we go. Okay. So for part D, we had 114 over 57. So when I made my factor tree for 114, we had 2, 3, and 19. So that's where I got 2, 3, and 19. And then when I made my factor tree for 57, it just split up into 3 and 19. So we just have a 3 times 19. Now I can go ahead and do my canceling. So the 19's cancel and the 3's cancel. So again, we have that weird thing happening where some of the things that are down below have canceled out. In fact, all of the factors down here have canceled out. So that means there's secretly a 1 there. And up top, we only have a single factor left. That's our 2. Now remember, anytime you have a 1 in the denominator, that means you secretly have a whole number. So 2 over 1 is the same as 2. All right. So that is how you can use your prime factorization to help you simplify fractions. The one sneaky part that you have to remember is when everything cancels, it's not 0. It's a 1, either in the top or the bottom, wherever it might happen. All right, so I've got a few questions for you to try here. So you can simplify each of these 4 fractions using the technique of prime factorization. In our next set of videos, we are actually going to be going backwards. So we're going to unsimplify fractions. And we'll talk about then why we might want to do a thing like that. So in the meantime, I hope you found this video helpful, and I'll see you soon. Bye for now.